The next speaker is Stefan Doerr, and he's going to talk about his experience in Canada.
Thank you very much. Now this is going to be a little bit different. It's not, well, it is about prescribed fires, but it's about prescribed fires that are as similar as they can be to a wildfire, and I want to go into a bit more detail why that is the case while we are making the plea for experimental wildfires, basically, a specific type of prescribed fire. Now step back a little bit, I'm going to talk about the example of the Canadian Boreal Community Fire Smart project. Some of you will be familiar with this. My co-authors are Christina Santin, also from Swansea, Ray Ault and Greg Baxter from FP Innovation in Canada. They put a lot of the material together, and also Larry Nixon and Wesley Steed, who are the past and the current wildfire management of the Northwest Territory in Canada. So why do we ask for more prescribed fires that are similar to wildfire? Now we all know that laboratory burns and also prescribed burns that are used for fuel reduction burns, they have led to many advances in research. We heard a lot about these, particularly the latter one over those 2 days, also in operations as well as training, but we're also all aware that they will not give us the full insights into all the aspects of many of the characteristics and impacts of wildfires. So this is really what we want. We want a little bit of magic and generate some real stand-replacing crown fires. That's easier said than done, of course, and I took this picture in the Missoula Fire Lab, not realizing that I was actually seeing my own reflection in the image until I got home. So I was a little bit surprised. So this is really what we would like. And this is an example from the Canadian area that was set aside for burning back in the 1990s. So a very prestigious project. Many of you will have probably heard about this. The International Crown Fire Modeling Experiment was run with a huge effort over several years. The location is in the Northwest Territories, a long way from any major population centers. So what they did at the time, they set a forest parcel aside that was surrounded by, or is still surrounded by, swamp, which was believed it wouldn't burn. It actually did burn in a wildfire a few years ago. But many of these parcels were burned in the late 90s and early 2000s, particularly for fire behavior research. Some of these were not burned back then, and they are still available, and some of those have been burned for research and management purposes over the last decade or so. And I'd like to tell you a little bit more about what has been done in those particular fires. So the original research, there were 18 experimental crown fires, primarily done to study crown fire behavior. One aspect was to calibrate a Viennese fire spread model, but many other aspects of fire behavior have been examined in those. But there were also aspects of testing firefighter protective equipment, like these NOMEC suits, for example. They were looking at environmental impacts, also atmospheric chemistry, for example, smoke, and many other aspects. Funding for that program was then reduced, but the program is still ongoing, and maybe some of you don't know that it's still ongoing. So basically from 2001 until present, this site was being used to examine firefighter safety, also fire behavior, structural protection, product testing, fire smart guidelines, impacts, and firefighter training. And I'd like to give you some examples, only a few examples, of what has been done over the last few years in this particular site. So for example, firefighter safety. They examined the necessary size for a survival zone which is considered safe for firefighters to survive a fire, which is quite contentious. Another thing was suppression equipment and, for example, fire shelter testing. I'd like to show you a little bit, if that works. Yes, here's a short video, if I can get into it. I can't see a mouse on this one. Okay, let's skip that, that's a pity. But anyway, that's a short video you can actually watch on the NASA webpage, and basically a few scientists from NASA, they were working on a particular material for re-entry vehicles, and they realized that this material should be superior to the current material that's being used for fire shelters. So they took this material up there to Canada to test it, assuming it would work really well, and in fact it did work really well. It's a really interesting video. If you watch it online, you search NASA fire shelter testing 2015. But what they also realized is during that particular fire, that nobody would have survived in those fire shelters simply because the fire shelters weren't sealed sufficiently to the ground. So it's the fire shelter design rather than the material that would have actually led to deaths in this particular fire, which is something that would have been difficult to test in the lab. So from that perspective, a very interesting experiment. If you go on the webpage, they actually don't tell you that the firefighters wouldn't have survived in these circumstances. But an interesting type of experiment. They also looked at structural protections, for example, sprinklers, gels, retardant drop effectiveness, and wraps, building wraps, so protect the building from being consumed in the flames. So here, for example, is a building that has been wrapped up with a specific material that certainly protects the building to a degree, and you can see only to a degree. That is the building after the fire. Now, the team there wasn't actually too disappointed because the fire was such severity they actually did expect that under those circumstances it would burn down, but they didn't quite expect the fire to be quite so severe because most of their data loggers were also consumed in the fire even though they were buried underneath the shelter. That was the fire. And our data loggers that we buried in the soil for other experiments, they did survive, so we dug them in deep enough. But what we, for example, did in this particular fire, as scientists, we wanted to know what are the temperatures close to the ground surface and above the ground in relation to carbon dynamics in this experiment. And we had temperatures up to 1,000 degrees on the ground surface. And the data loggers are only maybe 5 to 10 centimeters below. They survive that type of fire. Some of the testing of developments there are foam sprayers, all-terrain vehicles, heat flux sensors, fire cameras, thermocouple and infrared sensors, and the ground-based terror torch. And I'm going to show you some other examples of those now. So these are, for example, cameras. Some of them are used near the fire, some are used inside fires to monitor fires. I think you're all familiar with videos like that. Interestingly, in this particular fire, they were outside of the fire and they were still damaged. So again, the fire severity in this particular fire was beyond what they had expected based on the meteorological conditions, the fuel available. So the fire severity was greater than had been expected on this particular day. This is another interesting piece of equipment they were testing there, what's called the terror torch. So if you don't really like using drip torches, that's another alternative. Probably the most important aspect that has been examined in this particular environment is FireSmart validation. So FireSmart, you probably most of you are familiar with FireSmart itself or similar programs. This is simply programs to protect communities from either fires themselves or impacts of fire. So increase the suppression capacity around built-up areas. So for example, will thinning work? This is one of the few opportunities where you can really test and set a forest on fire and see whether the thinning that you think will reduce perhaps fire severity will actually work under particular conditions. Cleaning, for example, on the right-hand side, lower right-hand side, you can see a fire break that is covered with mulch. Is that fire break actually sufficient under certain conditions to stop the fire, or will it at least allow more sufficient fire suppression? In this particular case, neither of this was the case. For us in particular, so me speaking as a scientist, not as a manager, we are very interested in the fire impacts. Now, for these particular fires up in the Northwest Territories, it's mainly management research. It's actually relatively little hardcore scientific research, as I would say it. But what we're specifically focusing on is the carbon balance of fire, the carbon sequestration, for example, via charcoal production, also vegetation regeneration, also pollutants in ash. And again, where in the world can you examine this directly in a high severity fire? There are very few opportunities for this. Just to give you an example, what we can do here and what's a real requirement to carry this research out very thoroughly is to examine the plot in great detail before the fire. This is something you can't really do in a wildfire. So we basically took samples over several days, did a detailed fuel assessment, buried thermocouples, and then went back after the fire and did exactly the same. You could see Christina is having good fun on the right-hand side. It's a really, really nice nice task. It's great fun working in the field. But ultimately, we actually managed, and I'm not thin slicing here, we managed to publish 3 very different papers based on one single fire. So the wealth of information, it's not that we're good writers or anything, the wealth of information that we got from a single fire with the help of colleagues was just overwhelming. It's been a really fantastic opportunity, and those opportunities are rather rare, and this is basically why we're calling for more fires like this. But that's not the only reason. But I'll just highlight one single scientific outcome for this particular one. We found that over 20% of the burned fuel was actually not emitted to the atmosphere. That material was not emitted, but it was converted into carbon-rich charcoal. And in the literature, you find figures between perhaps 2 and 5%, and this is why this is usually neglected in atmospheric modeling and carbon budgeting, because it's believed it's not a big enough figure. but it is quite a big figure. And this particular figure has been confirmed in other environments since we've done this research, at least roughly speaking. So it's an important parameter to be looked at when you do carbon modeling of fire. But I'll move away from this specific science again and just show you a little bit more of what impact this research has had. Now, up in the Northwest Territories, they not only use a few scientists and the managers to run those fires, they produce a lot of material. So they take videos, they produce pamphlets, they generate presentations that they then take to local authorities, they take to small villages and show them what can happen if you, for example, thin your forest, if you have a fire break, what that will actually do to the community. But they also bring some of the population close to the fires, not super close, but close enough for them to observe what a wildfire actually looks like. Because a wildfire, to see a wildfire close up is, for those of you who have, and many of you have, but for most others, the normal population or scientists, we rarely see a wildfire close up, and it's pretty staggering how that is compared to a normal fire a normal prescribed fire in terms of flame length, in terms of fire spread, in terms of radiative energy. And of course, another really important aspect is firefighter training. You need firefighters to carry out these fires, but of course the material you get there, the training videos, but also involving firefighters directly is a real eye-opener. So every time we've been up there, and we've been up there now 6 times, 5 times, we'll go up again this summer, the firefighters that hadn't been to a wildfire so far, they were really shocked what an extreme fire will look like. And of course, for them in particular, those validation of techniques and guidelines is very important, because if you can't demonstrate to the management, to the population, to the local government that a fuel reduction, for example, or thinning is really effective, it will not be taken up. But if you can do that via videos, via presentations, and via some hard data, it can be very effective. And of course, as I said, now the scientific advances for us from the scientific community are great, but this is only a small part why these streetcar burns are really important. Just to give you another example, this program that's supported by the Northwest Territories government nearly died because the fire managers higher up, they believed it was just too much hassle. And so last year, 2 of the top managers came with us to see one of those fires, and they were completely converted after seeing what kind of benefit educationally they can get out of it. So the program, at least for the time being, is continuing. And of course, I talked about this before, development of equipment, of in-fire cameras doesn't always work, sensors, shelters doesn't always work, structure protection doesn't always work. That's always also important in terms of getting that knowledge. Now, just a few more words about the challenges, solutions, and opportunities with this. Of course, safety is the top priority. So for us as scientists, if we want to be involved, we need to be trained. And of course, firefighters need to be involved, but that is a good training opportunity to get firefighters involved in the program itself. We've had training from the Creu Costa Foundation, from Graf, here near Barcelona, so we're very grateful for them. That's been fantastic training that they acknowledged for us, and I can really recommend it to anybody who hasn't done that training. But you also have to talk to the landowners, the local population. So, for example, smoke, which was mentioned many times, it's really important to explain to them why these fires are being carried out. They're not only a nuisance, there are, but the benefits of those fires. And finally, just one more slide about another opportunity that we were fortunate enough to be involved with in terms of a normal prescribed fire used for fuel reduction. Within that, there certainly is an opportunity, we'll be lucky enough to use that. If you set aside an area within a prescribed burn for fuel reduction that you can safely burn at higher severity because all the rest is burned at a lower severity, that's really good for training, that's really good for scientists. It's a relatively small price in terms of ecology because a small area being burned, you can get a huge amount of information out of this, and we've been fortunate enough to do this in Sydney's water supply catchment. They've been burning an area for us at relatively high severity, and that's been like gold dust. So with that, I'd just like to finish and hope there'll be more opportunities for examining hot, or shall we say wildfire, similar prescribed fires for the benefit not only of the scientists, but also for the benefit of firefighters and the management community. Thank you.
We are running out of time. Then you have Stefan here today and tomorrow. You can make as many questions as you wish. Thank you, Stefan. Sorry.